We have Billy with the talk title Speedruns Onchain. Intriguing to hear what it's going to be about.
Cool. So, begin the talk by saying that Unchained games are bullshit. I actually do kind of believe that. I think that they don't have to be bullshit, but they are mostly bullshit today. They're bad, it's hard to play, there's a lot of reasons. I'll get into some of those, but I think the goal of the last talk and this one is to improve that. One of the ways I think that can happen is by putting speedruns on chain, making blockchain games fast. So before I go into that, quickly about myself, Billy Rennekamp, founder of Trifle Labs, recently left 1KX as entrepreneur in resident. Prior to that, I was at the Interchain Foundation with Cosmos, been running an NFT gallery called Folia with collaborators, and my first crypto project was called Clovers back in 2019, early NFT and AMM project. But why on-chain? I mean, we saw a slide like that, very similar, and I think that we're at a moment right now, a pretty critical moment in the industry where we've been moving the goalposts back over and over again about like, what do we need until we're going to have the first billion users? You know, it's just not fast enough. It's just too expensive. The UX is still just too bad. I think that we're getting to an inflection point where the tech is basically good enough, where we have to stop making excuses. I think we've seen a lot of success with DeFi products. They really do have interesting, novel, and better mechanics than a lot of what we've seen before. But I think that this, we're still missing the kind of like killer app that brings new users on, that sort of justifies all of the time, money, and effort that we put into building this tech. And I think games are a really viable category of applications for that. So the reason that you would want to go through the effort, of course, of putting a game on chain, it's not fun. The tech is still bad, and it does make the user experience harder to get through. So what are the actual benefits that you would do to make this happen, besides the fact that you're trying to create an app that people will use? So I was working on these slides last night at the same time as trying to get our next playtest, so wherever I'm missing an image, you'll see Clippy here. Apologize for that. But I think there's kind of 4 reasons to go through the effort of putting a game on chain. And the first one is persistence. So persistence is a bit like what did you say? It's like the thing that makes a game more valid, more justifiable, or something like that. But I think it's generally this idea that like this thing will last. I can invest my time into it and not be disrupted. And you know, there's this story that Vitalik created Ethereum because he was playing World of Warcraft and one of his characters got changed through an upgrade. This idea that you couldn't trust the game developers to be delivering what's in best interest for the players was this idea that, oh, we need like a more reliable game engine. We need a more reliable world computer where I'm not going to have my players' characters rubbed out of me. So what began as like a small thing resulted in building an entire Ethereum cryptocurrency. And it's just this idea that it's reliable, it will last, I can invest my time in it, I can invest my future, and maybe I can build a secondary application on top of it. I can compose, which is the third one, not the second one. This is community ownership. So community ownership, this is the idea that because this thing is fully on chain, the operation of it is slightly out of the hands of the original creators, and there's the opportunity for the community itself to be operating, changing. There's a tighter feedback loop between the people who play it and the people who deliver it. Community ownership, of course, has a double-edged sword. It's very easy to think I'm going to exit the community and no longer have the responsibility of making a valuable game. The community is going to take care of that, but I think that we've seen across the industry a lot of projects fail because you expect the community to show up, you expect the community to do the work, and it's really difficult to expect strangers to walk in and start, you know, working full-time delivering a great product. And so while I think community ownership is huge, I think it's also a double-edged sword, and one that you really still need to build a valuable product before you sort of expect your community to operate it. The third one is composability, and I think this is probably the strongest argument. And I've got pictures of battle bots here. And so BattleBots was a popular game where people would build robots to battle each other, and whichever robot was left standing was the winner. And I put this on here because I think composability is especially useful for people who are building bot players, which is a little ironic. So it's the double-edged sword of the composability argument. On one side of composability is that we've made this system that has reliable APIs. You can inspect the entire application state. Makes it really easy to augment the application, to build add-ons, third-party products, etc. But it also, at least in the context of games, makes it very possible for often your least wanted users to have superpowers that you don't want them to have, which is that now they can build a bot who can play the game way better than a normal person could, and it very quickly devolves into bot versus bot as being the sort of most viable activity. And the final reason is value as a primitive. And this is just simply, I think, a more elegant and cleaner way to build applications. Today we have apps that often represent money or value in the form of integers, numbers, or doubles with decimals. But those numbers all sort of represent value that have to be enforced through traditional institutions like PayPal or Venmo, who really sort of move the money at the end of the day. You have an account balance, but it's not the same as being the actual nitty-gritty stuff of money, the same way that a currency inside of a smart contract can itself be the money itself. It's not representing money that exists somewhere else. And it's just a much more efficient system of building software that deals with valuable primitives. And I think that there's a lot of leverage to be taken in that area. And of course, the types of apps which can benefit from this the most are DeFi and gambling apps. But I think that we express value in a lot of different ways. That idea of persistence, Vitalik has a lot of value embedded in this character. Might not have a really strong secondary market, but the idea that it can be traded is already built into it. It's just a much more efficient way of expressing value. So we have some justifications here, but a lot of it actually has been wrapped around in this term of autonomous worlds, which I think is a great way to sort of express the persistence idea. And that is that what happens when you build a system or a game that lives on beyond you? Something that is much bigger than any individual company or creator, something that other people feel invested in building space on top of, living inside of, and that'll go on after you die because the architecture and the technology that's running it can't be check. We have another mic. Johnny. I think I fucked this up. Check. Autonomous worlds. They can't be stopped. You can continue to run the system way after you would be alive. But I think what's actually most exciting about this term autonomous worlds is that these ideas have actually been around since the beginning of people building a blockchain. Of course, like I said, the sort of goalpost of what do we need to be able to deliver this stuff has been longer and longer. But I think that we've seen the first wave of on-chain games occur in the last couple of years. And the reason autonomous worlds, I think, has had a resurgence is that it's more like a recommitment to actually build games that don't sell out too quickly, that don't compromise on delivering products that have these ideals sort of fully expressed. And so, most of all, I love this term and this sort of movement because it's a commitment to do better going forward. But let's go back. Why today are on-chain games bad? And it is still a lot of these technical limitations. There is still very bad UX. Dealing with private keys is hard. Gas is confusing and expensive. The on and off ramp process is still a pain in the ass. But one of the big things I think is just this idea of bad users, and I don't blame the users for this, but essentially, airdrop farmers, speculators, these aren't core loop gamers. They're not there to play a good game. They're there to sort of test whether or not this game could be good and whether or not there might be a speculative value in purchasing some sort of an asset that's with it. And often those two things cross over and they will play the game, essentially sort of confirming that it is a playable game, but it's not like they're playing it because they want to play the game, very seldom at least. And I think that this really makes the developers build games that look good, or look like they would be fun, or look like they will be successful, or make it possible to raise more money, but they're not actually trying to iterate on a game loop that is fun. And I think this is really hard because when you're dealing with an on-chain game, of course, value is a primitive. Everything built into it could be essentially a speculative asset. And so it's very tempting or very confusing sometimes to be able to tell, am I building a core game loop that is attracting the right kind of activity that I really want, or am I actually trying to get activity that just justifies the fact that I'm doing this? It's a double-edged sword. I mean, early speculative interest is a great way to sort of bootstrap a product, but I think that it can really bite you in the butt if all of that speculation drops down. And I have pictures on the left of, I think it was called Pixelmon or something like that, a project that raised $70 million and then delivered this extremely subpar product because the whole thing was a hype cycle in order to continue and justify its raise. But at the end of the day, somebody had to finally ship a game, and it was bad because they just were more focused on their product and the visuals than actually making a game that people wanted to play. So the other reasons, though, are a bit more technical, and that's what I'm going to spend more time talking about. And that has to do with limited computation, expression, and limitations on speed. So speed and complexity. Right now, we're kind of in this grid-based movement world. When you have an EVM, especially, or a blockchain that relies on the block update function to sort of write your code logic, you end up writing very, very minimal games of a very sort of specific type. It's essentially, we're living in board game mode of the world. Each action can be relatively simplistic, but it can't keep going because it needs to collapse inside a single block. It can't get too much gas. And so you make these grid-based games. And there's a lot of really great grid-based games out there. I think it's just a very specific category. And you see almost all of the games out right now are limited in this kind of capacity. I would love to see a lot more complexity being possible. On the right side here, it's just one small step up in complexity, but you can already see the difference in the sort of possibility space. This is Mario and Super Mario playing, and at any given moment, there's a sort of massive tree of movement options that are possible, even though this is really just slightly more complex grid space. It's just a much larger grid, moving much faster. And so what do we see right now as the options for sort of addressing these? One mentioned in the last talk is Mud v2, and this is really just a framework for writing more complex Solidity with the mentality kind of gas be damned. Okay, so let's deploy on L2s where gas is so cheap that actually we can afford to have relatively complex game logic all written in Solidity. The problem with that today is that Solidity is just not not made in a way to sort of make it possible to write complex applications. And so Mud is a framework that allows you to sort of build out larger and larger and more complex things. But it's still limited by the block time of that chain. So all of your actions take place in either 15-second increments, 5-second, 1 second. There's a lot of really clever things you can do with sort of optimistic updates, and I'll probably be there once that next block comes in, so I might as well display myself halfway there. Really, really great stuff, but you're still ultimately limited in this really restrictive way. And the other category is the one that I've been much more excited about, and it's the sort of larger description of what could be called Validium games. Might be familiar with the term Validium as a kind of roll-up terminology. It's a ZK roll-up. Basically where you run all of your application state off-chain, and then you prove that the output of that is correct using advanced cryptography. And you submit that update back into some clearing level with the proof that this outcome occurred. And there's sort of two categories that we see here. One is related to zero-knowledge virtual machines, ZKVM, and there's a wide variety of these, but they essentially allow you to write your program like you normally would, in whatever normal language you like, and then at the lower level processor, those update functions get converted to zero-knowledge circuits, and then that is what gets proven. The problem with that is that because you're doing it at such a low level, they become very large and complex proofs, and while these have generally a constant price and a constant speed at the verification level, that proving time takes a long time. So you do a trade-off. Instead of paying a lot in gas, you pay a lot in the amount of time you have to wait, and possibly the amount of computation power you need to be able to generate these proofs. And so the nice part of the ZKVM, again, is that you can use a traditional programming language, something that you're familiar with. Maybe you don't even need to rewrite your code, just has to be compiled differently. But then your users have to wait a long time, or you have to pay for really expensive hardware to speed up that whole system. So the cost goes somewhere else. I've been building a lot using Circom, which is kind of a handwritten circuits, and I have the description here, hard out fair, because it is extremely difficult, but it has a lot of the other benefits that you like, in that it's faster and it's cheaper, and you're able to still be quite expressive with it. So I'll go into that now. But generally, both of these Validium game types, they escape the problem of slow block speed times by doing basically play first, verify after. And this is where you have your entire game written in your zero knowledge circuit, and you play it in whatever sort of game environment you want. You remodel the entire circuit in two different places, one in your traditional game engine, and then one in this advanced cryptography. And then you take the input of your play in the normal game scenario, and then you put that into your circuit proof, and you're able to say, okay, the play that came out is the same. So let me just go over that again, actually, with a little more detail. Before I do that, I'll point out what circuits look like. So you've probably heard zero knowledge stuff before. It's a little bit like programming. It's not quite. Circom is probably the most widely deployed production circuit language on EVM. It's by Idem3, which was one of those ZK teams that got acquired by Polygon. It was used in production by Tornado Cache, for example, and all of the world-colored things are written in Circom. On the left here is an example of what it looks like to write the function is0, which is just trying to figure out, is this number 0? And it's almost like a programming language. It's basically like math tricks to make true or false statements about things. And so the input here is some number, and then through this like very clever math trick, you're able to sort of determine, without using subtraction or division really, that this thing actually is 0. And so it's kind of like really bizarre ninja tricks that eventually result in things that basically look like code logic. But the trade-off for it is that you're able to make really fast proofs, really small proofs that a user could create in their browser very quickly, rather than, as I said, using one of these like Kruger networks or dedicated hardware that takes hours or lots of money to build. And of course, blockchain does love to suffer, so we're happy to take on the trilemma of suffering as development requirement rather than the cost or speed. But the general flow of a Validium game is that there's a public input and a private input that goes into this cryptography thing called a prover. The public inputs are essentially your initial game state. So where are all the characters? What position are they in? How are they moving? How many points does whoever have? You take all of the things that are relevant to your game, and you make those public inputs to this prover. What's really exciting here is that you can also have private inputs, because zero-knowledge applications are good for two things. One, verifiable computation. They can prove that something happened. And the other is that they can run some computation with private information so that nobody else can see how you got to your end result, but you can still prove that you got there. So this scenario, the private inputs are basically users' input or keystrokes. If I was playing a game and I wanted to beat your score, but I didn't want to reveal what moves I used to beat your score, this is exactly how I would do it. I start with the initial game state. I keylog basically every stroke that I make on my keyboard or on my remote controller or whatever it is, and then I put both of those into the provers. They will run the entire game logic with those inputs and create an output, which is the final game state, including things like speed or score, plus a fraud proof, which is able to prove that this final output came from this initial input, plus some super secret user input that I'm not going to reveal to you. To give you another example of this, this is a screenshot from a book that was published in the 2000s called How to Win Super Mario Brothers. And so somebody took a Super Mario or a Nintendo Entertainment System controller and attached it to like a keylogger, basically. And they converted the left, right, up, down, B, A buttons to essentially guitar tablature. So if you've ever like refused to learn music properly but wanted to play a guitar, you can use tablature. And it's just this sort of like 5 lines, tells you where to push down each string. It's way easier than being an actual musician. So this is guitar tablature for playing the game of Super Mario Brothers. So they're keylogging every single stroke that you play. This entire system could be replayed automatically, and the exact same game would occur from the exact same user input. The system itself is deterministic. And so when it comes to a zero-knowledge system like this, you would be able to model the game of Super Mario Brothers in your ZK circuit, and then the input would be all of the strokes that somebody pressed while they were playing. And then at the very end, you'd have the output, which would say, here's a game of Super Mario where all of the levels are cleared, and I'm able to prove that somebody actually beat this game without telling you exactly the buttons that they pushed to get there. So this is the general format of how you can make really, really fast off-chain games that have relatively high computation and aren't limited by the state update function of the block to play as much and as fast as you like. And then again, is where you come back into your traditional sort of game engines. All you need to do is to be able to model the same game logic in two places. One in your actual game engine, and then one inside your ZK circuit. And this allows you to do speedruns. So if you're not familiar with speedruns, speedruns are a very popular form of playing games. Essentially communities who become extremely competitive and trying to be the best at any sort of game, and they shave the score down further and further. This is somebody beating Super Mario 1 the entire game in under 5 minutes. And it's generally set up like this. You have a video recording yourself, and you sort of show your stats, and you submit them to be sort of verified by a community who says, you know, oh, I believe that he really played it based on the authenticity of the video or the realism of the recording. However, people take it to extreme extents. You can kind of speed run anything. People started speed running music editing software. This was the fastest time that anybody ever recreated the entire Soulja Boy Crank That song in under 17 seconds. But there's also this problem of authenticity. So somebody recently got debunked on a Minecraft speed run, and everybody freaked out because they all believed it was a real speed run at first, but they didn't really have proof, and then somehow it found out. And what's really nice about this whole system is that you have this cryptographic certainty that this game was actually played according to the rules that we all agreed on, with the only sort of known method of doing it. And so we started a game company called Trifle, where we're going to begin making speedrun-based games, sort of in the arcade model. And the first one we've been working on is called Anybody Problem. It's based off of early Asteroid games, so there is still some limitations in the computation here. We had a goal of keeping it possible for a user to play the game in the browser and generate a proof in under a minute, which means that in the Circom language, we have to keep it under what's called 1 million constraints. And a constraint is basically just like an operation. And if you do that, that means that you can have the user download a relatively large file, but a file that is publicly available can be shared as many times. And with that file, that's the prover file, they can play the game and prove it under a minute. So this is a very early version of it. And like Asteroids, we began with this idea of bodies in space moving around. This is actually using Newtonian physics. This is like the three-body problem, essentially. So the way those things are moving is based on the gravitational pull between them from their mass and their position, and then they all move around each other accordingly. And so the first sort of simulation here is just them moving in space. And in order to keep the proving time under a minute, we were able to make an animation that lasts 20 seconds at 25 frames per second before the proof needs to be generated. So while doing that, we realized that this Asteroids game type was actually really achievable, and so we made a new version where you can, of course, kill these things. Now that added more constraints, but we found other ways to reduce them. Here we are still within that 1 gigabyte prover file, 1 minute proving time, and this allows you to have 26 seconds at 25 frames per second. Now moving forward, we decided to really up the ante, and now we are working with a system that has up to 10 bodies that can play. Our game is 60 seconds. This is the first sort of game that we've been working on. And that means that there's 3,000 steps in each game. We're running it at 50 frames per second, which means that it's a 1 minute long game, and there's 10 levels. So we had to chop up each level basically into a number of proofs in order to keep these, as I said, sort of under a gigabyte and under a minute for each one to be proven. So when you're playing the very first level, if you beat it as fast as possible, you only need to generate one proof, and it's a 10-second proof, and so that goes quite quickly. If you were to get to the 10th level right now, the proofs have to get more complex, and so without our latest optimization, it can take up to 10 minutes to prove the entire game, which is kind of terrible. But we're setting up a server so that you can always verify it yourself if you'd like to, but if you'd like to have a faster way, you can just send it to our server and we'll verify it in under 5 seconds. Now, this is a central point of failure, but it's not completely centralized because anybody could run this. All of the code to be able to do it independently is still available. And then all these get batched into a single transaction, and we're also working with a company called Nebra to create an aggregated version of these proofs so that it's not that you're submitting 10 proofs to be one level, you can really make a proof that these 10 proofs exist. It's recursion that really reduces the sort of time requirements. And so the game is live, playable in a very early version. It's on Sepolia and Garnet. The URL is anybody.trifle.life, and the password to play it is NP as in no problem. We're also doing play tests after this talk downstairs, but it's a daily problem. It's a bit like Wordle. So every day there's a new problem, and it runs until midnight UTC. And we have a leaderboard for who can beat that problem the fastest. And a problem consists of 10 levels. I think right now we're just doing it with 5 for brevity's sake. But every time you kill one body, you get re-challenged with a new additional body that you now have to kill as well. And that goes all the way up until the max level, and then you've completed that day's problem, and you can see each level itself has a contest, and then the entire completion has its own contest. So we also have a global rank, if you've been able to stay on the top of the rank board for a long time, and a longest streak. So if you're able to be consistently coming back every day, solving the level, you can build your longest streak. And then the most solved, of course, is just people who play it the most, even if they weren't able to do the streaks. It is coming soon to an EVM near you, likely July. One of the nice things about this game is that it doesn't need to have a global state, so it can be deployed to multiple blockchains at the same time. You can kind of choose which network you'd like to play it on. And if you want to do play tests after this, or you're unable to get it downstairs, please DM us on Twitter. We haven't actually even announced the company yet, but we do have a Twitter now, Trifle Life. Trifle.life is the URL, or you can get a hold of me, Billy Rennekamp. That is it. Are there any questions? Oh. Thank you.
Yeah, how do you deal with time? I didn't understand that exactly. Like, how do you global unit time? How do you get it into this proving system, or how do you make sure that I just don't watch the game state and later on come into a proof and backdate it or something like that?
So the game state is on-chain. The game state is the initial state of the problem, we call it. And we know how many seconds there are in a day. And so we can take the current timestamp, which is available in the EVM, in Unix time, and then we can modulo day, that number, and we'll get how many seconds is in the current day. You subtract that, and then you're able to get what day am I on since midnight last night UTC. And then we use that as the seed for randomly generating a new problem, which means for the next 24 hours, everybody's problems will be generated as the same starting conditions. And then when you play your game, that starting condition is the public input to that proof. So everybody's forced to have the same starting conditions. Their moves can all be different and random, but then the output says, here's where the game ended after these moves with the same starting point. So you submit the starting point and the finishing point plus the proof to the smart contract. First thing the smart contract does is say, is this the same starting point that you're supposed to have? Because I generated this game for you, I know what you should start with. Everybody has the same starting point. So it verifies all of those things, and it says, okay, I know that you started from the same conditions as everybody else, where did you finish? And then it checks your output, and if all of your bodies have been eliminated, then you've cleared that level. And when it comes to 24 hours, all it has to do is say, okay, am I still on the same day when you minted this? If not, then you can't submit this anymore. The 24-hour window is gone. You know, you missed your chance to compete in this 24-hour contest.
So basically, within this 24 hours, it doesn't really matter. I can't cheat because I'm fixed to that window, basically.
You have the same starting conditions as everybody else. I mean,
So the heartbeat is 24 hours for the game, let's say.
I mean, you can beat the game as many times as you want in that 24 hours. You can, you know, keep improving on your score, and you know, if you were the best and somebody else beat you, you can try again. But within that 24 hours, it's a contest who can submit the fastest, most efficient score, and then it starts again the next day. Mm-hmm.
Yeah, so the only shared state is the leaderboard, right?
The shared state on chain, you mean?
Yeah.
The initial starting condition of each level is on chain. The final level is on chain. The speed that it took for each one is on chain. and the history of the previous ones are all on chain.
Yeah, so whenever you think there's like a middle point where like people play this way where they're like doing stuff, but there's this like element of like players interacting with each other.
Can you ask that one more time?
Yeah, so right now I just like play the game and then I just interact with other players with like submitting stuff and then I have like a higher score than other people. Do you think there's like a middle point where like the game is like broken into pieces and then in between those pieces there's like some like interaction between players? So it's not just like I play with, I mean it goes with just like speed running, it's more like a multiplayer sort of thing.
Mhm.
It's like middle point where you're gonna do that.
Multiplayer is really interesting. I mean, one nice thing about blockchains in general is I think that every game is kind of by default a multiplayer game, just because you're all in this weird shared environment where you have access to each other's play state and your just existence is at the same time. The easiest way to make a single player game multiplayer is the leaderboard capacity. And the reason that it's hard to make these into multiplayer games is because that proof generation system is happening at an individual level. It is possible to do something like a state channel, where you're basically sharing information back and forth between players off-chain until you've sort of established the end of that multiplayer game. You can submit a proof that you all participated correctly, absolutely. Your suggestion to sort of break up the stages of individual play could also be an interesting technique to find more ways to interact. But the longer-term strategy for us to make it more multiplayer is actually when you finish the daily set of problems, you receive all those bodies as NFTs, and they become fodder for user-generated content. You'll have a level designer where you can sort of start building your own challenges, your own puzzles, and you challenge other people to play them. So that would be the sort of first direction we're going to go for making it more multiplayer. If you have any more questions, you want to play, come downstairs and we're going to play test.